ETC Rigging designs and manufactures world-class theatrical rigging solutions for the entertainment and architectural markets. With Prodigy hoists and quick-touch and foundation control systems, facilities are able to provide a new level of safe flying art previously unavailable to most venues. ETC theatrical rigging hoists were named Prodigy for their exceptionally smart, efficient, and safe performance. The Prodigy line of products has grown from a group of fixed-speed hoists and quick-touch controllers introduced in 2010 to include the V1000S variable speed hoist and foundation controller. New hoist and control designs are expanding the solutions available every year, and there is a long list of continuous product development. ETC strives to provide a quality rigging product from incoming inspection, component tracking, completed hoist testing, and final quality inspection checks. While some of these activities might be expected, certainly the completed assembly testing on Houdini, the ETC rigging test fixture, is unique in the industry. Houdini is used to ensure the quality of manufacture of every Prodigy hoist by testing all assembled components together in a system from motor to lift lines. I would like to introduce Mike Imhoff, manufacturing engineer, who will go through the ETC rigging quality system and demonstrate the Houdini rigging test fixture.
Here at ETC, quality is not just another step in the manufacturing process. Quality is a guiding philosophy that is used throughout the design and manufacture of hoists. Each part that is received by ETC goes through multiple checks to ensure it is up to ETC standards. Parts are first checked when they are received against the purchase order to make sure the supplier has sent the correct part. More complicated parts, or parts that are critical to the operation of a Prodigy hoist, are flagged for additional inspection. Each of these parts has certain characteristics and dimensions that they must meet. A member of the ETC quality department will check a random sampling of parts to ensure they meet these requirements. Only after the parts have passed inspection, they are put into stock and used in production. Serialization and component tracking are another area that helps ETC deliver a quality product. Each hoist and many subassemblies are given a serial number. This number allows ETC to track specific characteristics about the parts that are used in a Prodigy hoist. Some characteristics that ETC tracks are lot code of molded and machined parts, such as the drum, serial numbers of components like the motor, revision level of components such as the control board, and other various key characteristics. All of this information is collected and stored in our business system. Should a product defect be discovered, this information allows ETC to quickly and efficiently identify affected products to ensure the defects get corrected. Early on in the development of Prodigy hoists, we had an interesting problem. We have a product with a number of different lift lines, varying amounts of load capacity, and varying amount of lift line length. How do you test it efficiently and quickly? The answer, Houdini. Houdini is the final tester for Prodigy hoists. The first step in testing hoists is to load the hoist in the machine. You'll notice the hoist is located on the same cart that we build it on. Once in position, the I-beam is slid into place and the head unit beam clamp is firmly attached. Now that the hoist has been secured to the I-beam, we lower the cart and slide the compression tube into the compression tube receiver. The next step is to load cables onto the traction drum assembly. A loft block is placed in a Mario Kart and slid along a track where it is pinned in place. The wire rope is then wrapped around the traction drum 6 times and the take-up spool is placed on the take-up motor. The hoist is now loaded. We now have software. We're now ready to begin testing. The first step is to check the lower limit and the lower over travel limit. In order to test the lower limits, we first move the hoist to top dead center. We then adjust the limit switch so that it is in the correct location and verify that LEDs are functioning correctly and the hoist will not move when on limits. The next step in testing a Prodigy hoist is to calibrate the load cell. The hoist is moved to 25 feet of travel where, using the traction drums, we put a known amount of weight on it. We then run the calibration procedure. A critical safety function of the Prodigy hoist is the e-stop button. In order to test this, the operator pushes the e-stop button and then verifies the hoist will not move using the quick touch control buttons. He will then move on to the manual buttons on the back of the hoist and verify it will not move as well. After finishing the e-stop test, the hoist will be run to the top of its travel. There we will check the over travel and the upper limit. The next step in testing is to set up and verify that the Prodigy brake works. The first thing that will be done is a static brake check. To do this, we put full load on the hoist using the traction drums and then release the motor brake. we verify the hoist stops in a safe distance. Based on the results of this test, adjustments may be made. The next test we complete is a dynamic down brake test. This is similar to the static brake test. Again, we place full load on the hoist while it is traveling down, this time pulling the motor release lever. Again, checking to make sure the hoist stops within a safe distance. After completing a dynamic down brake test, we then complete a dynamic up brake test. As you can imagine, this is the same as the dynamic down brake test, except the hoist is traveling up. The next step is to verify the motor brake is working. This time we release the Prodigy brake and verify that the motor brake will stop the load as needed. We have now verified the Prodigy brake is working correctly. The next step is to cycle the hoist up and down in order to verify a number of key operating characteristics. These include line speed, cable-to-cable linearity, load cell accuracy, hoist current draw, and deadman current. The next step in the test process is to verify that the slack line detector is working properly. To do this, we lock up all traction drums except for one and run the hoist down, stopping the hoist when a slack line is detected. The next step for a variable speed hoist is a high speed test. The hoist is run from the bottom of its travel to the top of its travel at 180 feet per minute, verifying proper operation. The hoist has now completed its testing.
Now, we haven't been completely honest with you. The test process doesn't take just 5 minutes. It actually takes over an hour. A lot was covered in the video, so let's review what we test on our hoists. Houdini tests and functions include loading software, setting hoist personality, verifying lower travel and lower over travel limit function and indicators, verifying upper travel and upper over travel limit function and indicators, testing the override button functionality, verifying e-stop functionality, running a cable-to-cable linearity check, doing a travel speed test, doing a load cell calibration, checking load cell accuracy, testing for proper slackline detection, verifying deadman current, checking hoist current draw, running a high speed test on variable speed units, checking the motor brake, verifying the Prodigy static brake, and doing a Prodigy dynamic down brake and up brake test. Thanks for spending time with us in Houdini today. ETC looks forward to providing a quality hoist system for you in the very near future.